Ultra-processed diets do more than raise calories and pack on pounds. At the molecular level, they actively accelerate biological aging through a web of damaging biochemical processes that feed one another. What makes this especially dangerous is how subtle and cumulative the harm is. Single meals don't just cause transient effects. Repeated exposure reshapes redox biology, immune signaling, nutrient-sensing pathways, epigenetic marks, and even the ecology of the gut in ways that promote cellular dysfunction, tissue deterioration, and earlier onset of age-related disease. The trajectory from convenient packaged meal to accelerated aging is not metaphorical. It's biochemical, persistent, and often silent until the defenses are overwhelmed. One core pathway is oxidative stress. Ultra-processed foods are rich in rapidly absorbable sugars, refined carbohydrates, industrial seed oils high in omega-6 polyunsaturated fats, trans fats in some products, and heat-processed compounds such as advanced glycation end products, AGEs. These inputs increase mitochondrial workload and electron leakage, stimulate NADPH oxidases, and promote lipid peroxidation, producing reactive oxygen species, ROS, that damage DNA, proteins, and membranes. Oxidative lesions such as 8-oxoguanine accumulate in nuclear and mitochondrial DNA, impairing genome integrity and mitochondrial function. Damaged mitochondria produce yet more ROS, lowering cellular energy capacity and creating a self-perpetuating loop. The cell needs more ADP, turns up metabolism, leaks more ROS, and accrues more damage. Over years, this undermines organ function and shortens the functional lifespan of tissues that depend on high mitochondrial performance, such as brain, heart, and skeletal muscle. Inflammation is the next linked domino. The ROS and damaged molecules produced by processed diets activate inflammatory sensors, from NF-kappa B signaling to the NLRP3 inflammasome, prompting production of pro-inflammatory cytokines, IL-6, TNF-alpha, IL-1 beta, and acute phase reactants like CRP. Chronic, low-grade systemic inflammation, inflammaging, becomes the background state for multiple tissues, promoting insulin resistance, endothelial dysfunction, and extracellular matrix remodeling. AGEs produced during industrial cooking bind the receptor for advanced glycation end products, RAGE, and intensify NF-kappa B-driven inflammation, further accelerating vascular stiffening and atherosclerotic processes. This is not transient illness inflammation. It is a persistent metabolic inflammation that progressively erodes physiologic reserve. Metabolic signaling pathways that normally balance growth and repair are hijacked by ultra-processed diets. Repeated insulin spikes from high glycemic foods and constant nutrient abundance chronically activate the insulin/IGF, 1PI, 3K, AKT, mTOR axis. Persistent mTOR activation favors growth and storage over maintenance. It suppresses autophagy, the cell's garbage disposal and recycling system, reduces mitophagy, removal of dysfunctional mitochondria, and allows damaged proteins and organelles to accumulate. Suppressed autophagy accelerates proteostasis collapse and fosters the buildup of dysfunctional protein aggregates, a hallmark of neurodegeneration and many age-related disorders. Meanwhile, altered NAD+/NADH ratios and reduced sirtuin activity. Sirtuins require NAD+, compromise DNA repair and mitochondrial biogenesis, removing protective brakes on aging processes. Epigenetic remodeling is a critical but underappreciated mechanism linking diet to biological age. Diets high in sugar, processed fats, and additives alter patterns of DNA methylation, histone modifications, and microRNA expression, changes that can mimic or accelerate the methylation signatures used by epigenetic clocks to estimate biological age. These diet-induced epigenetic shifts affect genes controlling inflammation, metabolism, and stress responses, reprogramming cells toward a pro-aging phenotype. Importantly, some epigenetic marks laid down early in life are long-lived. Childhood or adolescent exposure to ultra-processed diets can leave an imprint that raises biological age decades later, increasing susceptibility to chronic disease even if adult diet improves only modestly. Cellular senescence is another downstream consequence. Persistent oxidative stress, DNA damage, telomere erosion, and metabolic strain-induced senescence in replicating and non-replicating cells alike. Senescent cells adopt a senescence-associated secretory phenotype, SESP, releasing pro-inflammatory cytokines, proteases, and profibrotic factors that damage the tissue microenvironment and recruit immune cells in maladaptive ways. Accumulation of senescent cells drives organ dysfunction, promotes fibrosis, and fuels systemic inflammation, essentially turning local cellular failure into organism-level aging acceleration. The gut microbiome and gut barrier function mediate and magnify many of these effects. Ultra-processed diets are typically low in fermentable fiber and polyphenol and high in emulsifiers, artificial sweeteners, and other additives that alter microbial communities. Loss of beneficial microbes reduces production of short-chain fatty acids, SCFAs, that ordinarily suppress inflammation, maintain gut barrier integrity, and modulate host metabolism. Simultaneously, dysbiosis can encourage growth of lipopolysaccharide, LPS, bearing gram-negative bacteria. Increased gut permeability allows LPS translocation into circulation, a potent trigger of systemic inflammation and insulin resistance. Certain processed meat-derived metabolites, for example, trimethylamine N-oxide, TMAO, further promote vascular inflammation and thrombosis risk. The gut immune-brain axis thus becomes another route by which diet-driven microbial changes accelerate cognitive aging and mood disorders. Protein and lipid modifications are rising from processing matter as well. AGEs cross-link extracellular matrix proteins, stiffen tissues, and impede normal cell matrix signaling. They reduce vascular elasticity and impair renal and cardiac function over time. Lipid oxidation products and chlorinated compounds formed during industrial processing are bioactive and cytotoxic, undermining cell membranes and signaling fidelity. These chemical insults accumulate, and because repairing or replacing structural ECM components is slow, the organism pays a long-term cost. Immune aging, immunosenescence, and reduced regenerative capacity follow naturally. Chronic antigenic stimulation from persistent inflammation, microbial translocation, and metabolic stress exhaust immune cell repertoires, skew hematopoiesis, and blunt vaccine responsiveness. Stem cell niches are damaged by inflammatory mediators and oxidative stress, reducing tissue repair and accelerating frailty. In tissues with limited regenerative capacity, brain, heart, pancreas, these effects translate into earlier functional decline and higher disease burden. Perhaps the cruelest feature of these mechanisms is how invisible they are while they operate. Many molecular changes, oxidative DNA lesions, altered methylation patterns, accumulating senescent cells, proceed without pain or obvious symptoms, only manifesting years later as diabetes, a heart attack, cognitive impairment, or frailty. The earlier and longer the exposure to ultra-processed diets, the deeper the molecular scars and the harder it becomes to reverse the trajectory. Some processes, e.g., certain epigenetic marks, mitochondrial dysfunction, are partially reversible with sustained dietary change, exercise, restored sleep, and reduced inflammation, but recovery is incomplete and slower with age. Early damage raises the baseline risk for later life. The warning is uncompromising. Ultra-processed diets do not merely add empty calories. They systematically attack the molecular mechanisms that keep cells youthful and tissues resilient. They increase oxidative load, lock in pro-inflammatory signaling, deregulate nutrient-sensing pathways, mTOR, sirtuins, insulin signaling, erode epigenetic stability, degrade the microbiome and gut barrier, and seed the body with senescent cells, all of which accelerate biological aging. Viewed across decades, frequent consumption of these foods is an intervention that shortens the functional period of life, raises the risk of multimorbidity, and reduces physiological reserve at the moments when we need it most. Recognizing the molecular consequences makes the choice to rely on ultra-processed diets not merely unwise but actively harmful to the pace and quality of aging.